Okay, so this is our second section on how to deal with non-right triangles. So we're going to use something called law of cosines. Now, if you have a choice to solve a non-right triangle using law of sines, that's going to be the easiest of the two calculations, sort of. This one's just a little bit longer, so you should try to do law of sines first. The law of cosines will work. And then if you can't, you have to use the law of cosines. Now, the most common time you have to use law of cosines is when you're given three sides and no angles. So if you reflect on the law of sines, obviously you need an angle and the opposite side. And if you have three sides, you don't have that. So that's how it goes. Now, for our class here, we're just going to focus on one formula, okay? And go about it that way. So instead of giving you all three, which there are if you rearrange the letters, we're going to focus on this one, that little c squared. So do you remember little c is a side? Okay, so it's always hard to make little c's and big C's, but I'll try to make it bigger. So little c squared is equal to, okay, the way we say it, a squared plus b squared. So that's little a squared plus little b squared. Okay, that's going to be this squared plus this squared. All right, and then there's another part here, though, which adds the law of cosines, minus 2 times a times b times the cosine of big C. Okay, so the way this pattern works, because you can rearrange the letters whatever order you want, the way this pattern works, though, is the big letter that's here, which represents the angle, it matches this little letter here. Okay, so if we relate back to law of sines a little bit, the angle that's at the end, the opposite side, is the one that goes here in a special place. These two pieces here, the A's and the B's, are interchangeable. Okay, because if you remember your basic math rules, you know, addition's commutative and multiplication's commutative, so the order doesn't matter. All right, but that's how you match that up. All right, so that's going to be the formula. Now what we're going to do is we're going to go through when you're given an angle and two of the sides, and you're finding the opposite side. Okay, then we're going to go over that, and then we're going to go through what happens if I'm given all three sides. How do I find a missing angle and try to go from there? Okay, so that's going to be the longer of the two. So let's look at number one here then. Okay, so this is a scenario here, though, where I can't do law of sines, because I have a 65 degree, but I don't know the opposite side. That's what's critical, right? So I have two sides. Can I do Pythagorean theorem on that? The answer is no, because I do not have a right triangle. Remember, all that other stuff we did is right triangle based. Okay, so I have to use law of cosines. Now, here's the key for this. This angle here is going to go at the end, okay, and the side that I'm missing, the opposite one, is going to go there. These two are the interchangeable. If you want to call them A's and B's, you can. Okay, so how does this set up? Here's how it sets up. X squared is the side I'm finding. It's going to be equal to, I'm just going to choose 7 as my A, 12 is my B, and again, it's just the two sides squared added together, minus 2 times the product of these two times the cosine of 65 degrees. So that's what goes in there. All right, so this is pretty much a calculator problem when everything's filled in on the right-hand side. So on your calculator, if you put all that in at one time on the left, okay, and again, we need you to practice that at some point to make sure you get the right answer. If you do all that, you're going to get 122. Okay, so I'm going to end up with x squared is 122. I think from Pythagorean theorem, we're familiar how to solve this. You're going to take the square root of 122 on your calculator, which turns out to be 11. So pretty cool if you think about it. If I'm given an angle between two sides and I gotta find the other side, I can't use law of sines, can't use trig functions, can't use Pythagorean theorem, this little formula right here will help you find that. Okay, so that's the basis for finding a missing side. Now, what happens if I'm given three sides and I have to find the missing angle? So let's look at number 5 here. Okay, that's where it gets a little more complicated, because then we have some work to do here for number 5, and it's going to take us a couple steps to get it. But here's what this one is, okay? So if I have that one right there, okay, notice that the angle I'm focused on this side, they kind of hold a special place, okay? And the special place is that opposite side is over here by itself. So 7 squared equals cosine of x. So I just want to emphasize that those two match up. Now, as far as the rest of the formula goes, I'm going to have the formula on the sideboard. You can look at it. Okay, you're taking the other two sides and alternating them any way you want. I don't know, Mr. Neisen's brain, I kind of go smaller to bigger, but it doesn't matter. So it's going to be 11 squared plus 12 squared is the pattern. All right, minus 2 times that product again is how that goes. Okay, now to solve for x, here's where it gets a little bit trickier. Okay, we have to do this in pieces and follow our order of operations. So it's very important that you kind of follow me here, because this is where students get messed up on order of operations. What I want you to do is you're going to find 3 values to start. These 3. Okay, and then I think it becomes an algebra problem with an inverse cosine at the end, if you can follow. So if I find these 3, I get 49 here, right? If you take 11 squared plus 12 squared, it's 121 plus 144. Let me actually go up here real quick. I'm not sure why. 121, 11 point, this is 11 point something, just so you know, 1 or something. Anyway, okay. So when I take 11 squared, I get 121. I'm not sure why that said that way, but plus 144, okay? Now, I'm going to erase that and just put that answer here, because I think you can just put that in all at once, okay? So if you do that, what that turns out to be for number 5, when you add those two together, is you're going to get 265 minus, now what you're going to do is you're going to take 2 times 11 times 12. So 2 times 11 times 12 turns out to be 264, which is kind of nice, and then cosine of x. Now, a common error is people do things out of order. You can't take 265 minus 264, okay, because of this times here. They're not like terms. So what's the first step we're going to do here? I want to solve for x. So now it kind of becomes, or solve for cosine of x, we'll say. We're going to solve for cosine of x. All right, so this is kind of locked up right here. So how do I solve for that? I think we know this algebra rule, right? We're going to subtract 265 to start from both sides. Okay, if you subtract 265, this is going to give me negative 216 equals negative 264 cosine x. See how I got that? So I'm going to subtract first. Now again, if I'm solving for cosine x, what's my next step? I'm going to divide both sides by negative 264. So if I divide both sides by negative 264, you're going to get cosine x equals we're going to keep a bunch of decimal places, 8182. Okay, so let's review what we did here. We took the angle on the opposite side, put them in their appropriate spots, filled it in with the other sides. But remember, I found those 3 values, so I have an algebra problem. Now, how do I finish this? Remember, to find an angle, what kind of trig function to use? Use an inverse trig function. So what this says to do is my answer for x, I'll skip down here quick, my answer for x is going to be the cosine inverse of 0.8182, okay? And that's going to give me the angle, because to get rid of this cosine, you can't divide by c, then o, then s, or divide by cos or anything. To get rid of it, you have to take the cosine of that, the cosine inverse of that side, which means I take the cosine inverse of the other side, and again, overriding rule is inverse trig functions find angles, and this would tell me that this angle is 35.1 degrees. Okay, now that's pretty cool if you think about it for a second, because a lot of times in measurements, I hate to use the term real life because nothing's real life, but do you agree in the real world you could find distances? You just have a tape measure and measure these 3. If I want to know this angle, there's no real life protractor that you can lay down, and I found that missing angle. So that's how you use law of cosines for that. All right, and again, why doesn't law of sines work? Because you don't have an angle in the opposite side. So I appreciate you writing those down when we have class. We're going to go over some more examples of those and ask